Okay, so in this video we are going to talk about some strategies we can use in order to compare fractions. So I am looking at the activity that is on page 166, and we will be using the table that is on page 167 in order to do this activity. Okay, so first of all, it says we are using this table and we want to sort the following fractions into the table. So 5 6 0 fourths, 5 twelfths, 18 twelfths, 1 tenth, 13 tenths, 11 twelfths, 1 ninth, 20 40ths, 3 20ths, 5 eighths, and 21 20ths. So our benchmarks. So when we're looking at fractions, the fraction is either going to be close to 0, close to or equal to 1/2, close to or equal to 1, or greater than 1. So those are our benchmarks: 0, 1/2, 1, and then greater than 1. So take a minute and place these fractions where you think they should go in the appropriate categories. And then unpause this video when you're done, and we will talk about the answers. Okay, so you should have, let's see, starting with 5 6. 5 6 is, well, it's actually already on here, right? So it is close to 1. Next is 0 fourths, so that is close to 0. 5 twelfths is close to half. 18 twelfths is greater than 1. 1 tenth is close to 0. 13 tenths is greater than 1. 11 twelfths is close to 1. 1 ninth is close to 0. 20 40ths is exactly 1/2 if you reduce. 3 20ths is going to be close to 0. 5 eighths is going to be close to 1/2. And then the last one is 21 20ths. So 21 20ths should be greater than 1. Okay, so then it's asking these questions. How are the fractions near 0 alike, near 1/2 alike, near 1 alike, and greater than 1? So think about, how do you know where these fractions go in these, with these benchmarks? So fractions near or equal to 0. The thing you should be looking at is, in order to place these, we are comparing the numerator to the denominator. So you can say that if it's near or equal to 0, the numerator is very, very small, or in comparison to the denominator, it is far away from the denominator. So you can tell if a fraction is near 0 if the numerator is close to 0. Or I should say is 0 if it would be exactly 0. All right, what about 1/2? In order to determine if a fraction is close to or equal to 1/2, again, if you're comparing the numerator and the numerator should be about half the size of the denominator. So 2 is half of 4, 3 is close to half of 8, 7 is close to half of 12, etc. So a number will be near 1/2 if the numerator is half or close to the denominator. Okay. What about fractions that are near 1? So again, looking at the numerators and denominators, fractions that are close to 1 but not bigger than 1 are going to be fractions where the numerator and the denominator are very close together. So 5 is close to 6, 7 is close to 8, 10 is 10, 11 is close to 12. So if the numerator is close to or exactly the denominator, and then finally, in order to tell if a fraction is going to be greater than 1, then the numerator will be larger than the denominator. So fractions greater than 1 are called improper fractions, where the numerator is larger. So numerator is greater than 1. So the numerator is greater than the denominator, I should say, not greater than 1. It reduces to be something greater than 1. All right, so to test this out, it says put each of the following sets of fractions in order from smallest to largest. So this is like two different sets of numbers, first of all. So in the first group, we have 2 twelfths, 19 tenths, 4 eighths, 5 sixths. Excuse me. And then it says use the symbol for less than. So if we look at these fractions, we have the first one. Is that closer to 0, 1/2, 1, or greater than 1? So that one is close to 0. 19 tenths, the numerator is larger, so that would be greater than 1. 4 eighths would be exactly half, so this one is close to half. And then 5 sixths, 5 is close to 6, so this one is closest to 1. So this one is pretty straightforward. So 2 twelfths is close to 0. So that would be less than the next one, which is close to a half, which is 4 eighths, which is less than, from the remaining, the one that is close to 1, so 5 sixths. And then finally, 19 tenths bigger than 1. Okay, try that with the next set of 4 numbers, or 4 fractions. So 4 fifths, 3 sixths, 5 fourths, 0 halves. So 4 fifths closest to 1, 3 sixths would be close to half, 5 fourths greater than 1, and then 0 halves would be close to 0, or it actually is 0. So again, so this one would be 0 halves, followed by the one closest to a half, which is 3 sixths, which is again exactly a half. And then 4 fifths is close to 1, and then 5 fourths is greater than 1. Okay. All right, what about question 6? Again, putting a set of numbers in order from smallest to largest. So again, this is 2 different problems right here. So something you should notice about these fractions, we have 2 eighths, 7 eighths, 5 eighths, and 1 eighth. And then our second set is 11 twelfths, 2 twelfths, 8 twelfths, 7 twelfths. So you should notice that in these, all of these fractions have the same denominator. So if you have things with the same denominator, or the same size pieces, how do you put them in order? So we can use a similar strategy. 2 eighths would be closest to 0. 7 eighths would be closest to 1. 5 eighths would be a little more than a half. And then 1 eighth is also close to 0. So we could use our benchmarks and know that 7 eighths is obviously going to be the largest because it's the closest to 1. And then 5 eighths would be the second largest since it is a little over a half. But then our strategy says we have 2 eighths and 1 eighths, and this is close to 0, and this is close to 0. So that doesn't help us much. So we have to think of another way to determine which one is smaller than the other. So again, since they are same size pieces, this is like you have an 8-slice pizza and an 8-slice pizza. So if you have 2 slices, that would be more than having 1 slice. So it should be 1 eighth being the smallest, and then 2 eighths being the next smallest. So it should be 1 eighth, 2 eighths, 5 eighths, 7 eighths. All right, for the next one, same sort of thing. Let's see, 11 twelfths is closest to 1. 2 twelfths is closest to 0. 8 twelfths is like kind of right there in the middle between a half and 1. So a half would be 6 twelfths, so 2 more pieces than a half. And then 7 twelfths is 1 more piece than a half. So we know that 2 twelfths would be the smallest since it's closest to 0. And 11 twelfths would be the largest since it's closest to 1. So again, how do you figure out which one of these is going to be larger than the other since they're both close to a half? Again, if you have 12 pieces of something, they're the same size pieces, so we would just look at the numerator, the number of pieces. So having 7 of them would be less than 8 of them. So it should go 2/12, 7/12, 8/12, 11/12. So you may notice it says, if 2 or more fractions have the same denominator, how can you tell which fraction is larger? So an easy way for if the denominator is the same, we can just put them in order by the numerator. So 1 is less than 2, is less than 5, is less than 7, and then 2 is less than 7, less than 8, is less than 11. So put in order of numerators. And I should say least to greatest. All right, so now the last question. What if we flip it, and this time all the numerators are the same, but now the denominators are different? So how are we going to put those in order? So again, 2 different sets. So we have a fourth, a tenth, a half, and a third. So let's see. So a fourth would be closest to 0. Or I guess it's 1 unit away from 0, but it's also 1 unit away from a half. So it's kind of right in the middle between 0 and a half. 1/10 is close to 0. 1/2 is 1/2. And then 1/3 is also close to 0. So we have a close to 0, close to 0, close to 0, and then we have 1/2. So we know 1/2 is the largest. Okay, so what about the other 3? How do we put them in order? So when the numerator is the same, we have to focus on the size of the denominator. So one thing we can do, if you flip this page back to page 165, we have these number lines. So one way we could do this is just look. So here's where a third would be. Here's where a fourth would be. And then down here, here is where a tenth would be. So let me try and move my camera so we can see them all at the same time. So we're talking about a tenth, a fourth, and a third. So think about the more pieces there are in the whole, the smaller those pieces are going to be. So if you have a number line cut into 10 sections, each section is going to be really tiny compared to, say, the number line when it is split into 3 equal sized pieces. Those pieces are going to be much larger. So we can see by comparing on this number line that the tenth will be the smallest. It is furthest to the left on the number line, followed by a fourth, followed by a third. So it should be a tenth is less than a fourth, which is less than a third. Okay. All right, and then the last one. So 3/5, 3/8, 3/2, and 3/10. So let's just check. 3/5 is a little more than a half, because half would be 2.5 fifths. So it's a little more than a half. 3/8 is a little less than a half. 3/2 is more than 1, and then 3/10 is what, close to half. It's closer to half than it is to 0, because half would be 5/10. So it's like 2 pieces away. So clearly 3/2 is going to be the largest. And again, we have same numerators, 3's, 3's, and 3's. So we have to think about the size of the pieces again. So 3/5 we said was a little more than a half, and the other 2 were a little under a half. So 3/5 would be next. So then we just have to determine which one is smaller, 3/8 or 3/10. So again, if we go back to our number line, thinking about 3/8 would be here, and 3/10 would be here. So again, tenths are smaller pieces than eighths. So the tenths are going to be smaller than the eighths. So it should be 3/10, 3/8. So 3/10 is less than 3/8, is less than 3/5, is less than 3/2. All right, so what do you notice about this? If 2 or more fractions have the same numerator, how can you tell which fraction is going to be larger? So here you should notice that when the numerator is the same, we can put them in order based on the denominator, but this time we're going from largest to smallest, because the more pieces there are, the smaller the fraction it will be. So tenths are smaller than fourths, which are smaller than thirds, which are smaller than halves. So we can put in order by denominator, largest to smallest. Okay. So those are special cases. All right. Okay, so now let's look at page 168. So this is called Why Is It More? So here are some examples of some fractions, comparing fractions. So again, I want you to take a minute and see if you can figure out which fraction is the largest. So it says which fraction in each pair is the greatest. And then be able to explain your reasoning. So we are using our benchmark strategies. So no calculators, no making common denominators. This is purely from just looking and thinking about how fractions are made. So pause the video, try these out, and then unpause the video when you're done so we can check your answers. Okay, so for A, we have 4/5 or 4/9. So the one that should be the largest is 4/5. So there are a couple of different reasons for this one. So one of them, what we just talked about, if the numerators are the same, if you look at the denominators, smallest to largest would be the larger the denominator, the smaller the piece would be. So ninths are smaller than fifths. So 4/5 would be larger. Fifths are larger pieces. Or if we use our benchmarks, 4/5 is close to 1, but 4/9 is a little less than a half. So 4/5 should be the largest. Okay. For B, you should notice that they have the same denominator. So when they have the same denominator, we look at the numerators and we pick the largest numerator. So having 4 pieces of 7 pieces is smaller than having 5 pieces of 7 pieces. Here's my cat. See his legs? Move him. So 5/7 should be the largest. Okay. All right, for C, C is interesting because, let's see, with our benchmarks, 3/8. 3/8 is close to a half, and 4/10 is also close to a half. So if you want to think about this, 3/8, how close is it to a half? It is 1/8 away from a half, and 4/10 is 1/10 away from a half. Okay. So since they are a section away both from being a half, we could focus on the 1/8 and the 1/10 instead. So so which fraction is larger, 1/8 or 1/10? So eighths are bigger than tenths. So the trick with this is you are missing a larger piece. So think about if you were running a race. If you were running a half mile and you were 1/8 of a mile away from the finish line, or you were 1/10 of a mile away from the finish line, where would you be closer? And I think we can go back again to look at our number lines. So let me pull these back up. So think about this. Here's the halfway point. Here's a half, and here's a half. So if we focus on this distance here. So being 1/8 away is this far, and being 1/10 away is this far. So since 1/10 is smaller, that means the remaining fraction that we care about is going to be larger than the 3/8. So since we maybe use a highlighter for this. So this portion is larger than this portion. So let me say this again. So since an eighth is bigger than a tenth, we care about the remaining part, the 3/8 and the 4/8. So since we have a smaller missing piece here, that means the remaining fraction we care about is going to be bigger than 3/8 is going to be. So 4/10 is bigger because it's only a tenth away. It's a smaller amount from being away from a half. All right, let's see, D. So same numerators, so we can look at denominators. So the smaller denominator means the fraction will be larger. So 5/3 should be bigger. And then on this one, it's obvious 5/3 is greater than 1, 5/8 is less, 5/8 is approximately a half. It's a little more than a half. So you have something bigger than 1 and then close to a half. So 5/3. E, 3/4 or 9/10. So here's again, this one is similar to C. This is close to 1, this is close to 1. So we have to think how close we are to 1. So 3/4 is how far away from 1? So 3/4 is 1/4 away from 1. And then 9/10 is 1/10 away from 1. Okay, so again, we would have to compare a fourth and a tenth. So just as I said earlier with C, a fourth is bigger than a tenth. So that means the remaining portion, the 3/4, has to be smaller than 9/10. So this one would be very good to visualize on our number line. So let me try and move my camera so we can see fourths and tenths at the same time. So sorry for my cat meowing right there. Okay, so if we focus on fourths and tenths, so up here, we are 1/4 away. So think about we're a fourth of a mile from the finish line. Compared to in tenths, we would only be a tenth of a way from the finish line. So if we were running a race, we still have a fourth of a mile to go, or we just have a tenth of a mile to go. So since a tenth is smaller than a fourth, the part that we have already done that we care about is going to be larger than the fraction up here that we care about. So 9/10 is way larger than 3/4 because it's a smaller missing piece from the whole. Okay, so that's why that one is 9/10. Okay, same thing with F. Let's see, 3/8 is what? A little less than a half. A half would be 4/8, so this is less than a half. Whereas 4/7 is a little more than a half. Half of 7 would be 3.5. So since this one is a little more than a half, 4/7 should be the greater fraction. Okay, what about 5/8 or 6/10? So again, close to a half, close to a half. So this time, how close is 5/8 to a half? So 5/8 is, let's see, it would be an eighth more than a half. So half would be 4/8. So this would be like saying a half plus an eighth more. And 6/10, if you think of it the same way, 6/10, half would be 5/10. So it is 1/10 more than a half. Okay. So 5/8 is a half and an eighth more. 6/10 is half and a tenth more. So again, we can just focus on this extra little bit since they're both a little more than a half. Now this one is slightly different since we're already at the half point and we're adding on. The larger fraction is going to be the one that has the larger extra fraction. So between eighths and tenths, eighths are larger than tenths. So in this case, 5/8 is going to be larger than 6/10. And let's see if we can verify that on our number line. So 5/8 is further to the right than 6/10. It's like just barely, but you can visualize that. So it's that extra eighth is bigger than the extra tenth from the halfway point. Okay, let's see. Similarly, so H, 9/8 or 4/3. So 9/8 is more than 1. 4/3 is also more than 1. So 9/8 is 1/8 more than 1. So 1 plus an eighth. 4/3 is 1/3 more than 1. So since we're adding, we look at again at the extra fractions. So is it better to have an eighth more than 1 or a third more than 1? A third is bigger than an eighth. So therefore 4/3 is going to be bigger than 9/8. Okay. And then finally I, which is similar to C and E, close to 1, close to 1. So how close to 1 are we? So 8/9 is a ninth away from 1. And then 7/8 is an eighth away from 1. Okay. So since we're away from 1, we're thinking about the extra piece. So if you still have, again, running a mile race, if you're a ninth of a mile away from the finish line, or an eighth of a mile away from the finish line, where are you closer to the finish line? So again, an eighth is bigger than a ninth. So if this is missing an eighth, that means 7/8 is going to be smaller than 8/9. Okay, so you're missing a smaller piece, which means the original fraction is going to be larger. Okay, all right, so hopefully you got those correct and your reasoning makes sense. All right, so then for homework, your homework is going to be page 171 and 172. So in 171 and 172, I give you two fractions, so you have to compare them just like we did. So no calculators, so don't convert them into decimals, don't make common denominators. So you are doing exactly what we did, talking about if they have a common numerator or a common denominator, talking about the size of the pieces or the benchmarks if they're close to 0, 1/2, 1, or over 1. So you're just going to say less than or greater than, and then write a reason. What is your reasoning behind picking whether it was less than or greater than? So there's 6 on the front, 6 on the back. Let me just show you. So 171 and 172. And then there's also another one on 173. So if you want some additional practice with these, you can also try 173. I won't be picking this page up for homework, but again, if you just want some extra practice and you want to email me and check your work on these, I am happy to talk to you.